So, this is it.
This is a quantum computer.
This is a quantum computer.
Hello people, welcome back to the channel. So today it's a video about quantum computers. So this quantum computers basically work like Linux, and it has bits like qubits, and it also works in quantum numbers. So it is very rare, so we'll react with Cleo, and she has a better knowledge about it, and she has been in person also. So let's get started.
I'm seeing a real-life quantum computer for the very first time with my friend and king of tech YouTube, Marques Brownlee. And I'm finally understanding why quantum computers are such a big deal.
Quantum computers.
Quantum technology.
What on earth is a quantum computer?
Bits, qubits. Try all the codes at once.
Whichever nation first develops a practical quantum computer will have a tremendous advantage.
Quantum supremacy.
I see a lot of news about quantum computers, and it's always extremely confusing.
That was really well done, and I still need to rehear it.
But also, it's often wrong.
So maybe this, whatever I have told you, may be wrong. So let's see what Cleo says here.
Quantum computers aren't supercomputers. They aren't bigger, faster versions of what we use now. There's something totally different. And that difference is actually the key to understanding why they're such a big deal, why governments around the world are battling it out to build them the fastest. Quantum computers are wild. They're on track to change what we can build and how we understand the world. They're kept at temperatures colder than
See, these are very minute things. As you can see here, these are very minute things, and it has basic electrons, and it is very delicate here.
big, important technology that we really didn't understand. So we decided to go on an adventure to figure out the truth about quantum computers, what they can really do, and why we should care. And of course, we're taking you on that adventure with us to show you what we learn as we learn it. And more importantly, to show you how these crazy computers might actually impact your life, and sooner than you think.
So let's see about the quantum theory, or a quantum video game theory, or this is an analogy given by Cleo. Let's see.
Here's the analogy that helps me understand what quantum computers are good for. Imagine that you're on a video game map, and how you get around depends on how good you are at doing math. You may not want to play this video game. Bear with me. So first, there were no computers. Things like geometry and astronomy took forever. So you have your little pencil and paper, and you're traveling across the mathematical map by walking. So it was slow, and there were lots of areas that we just couldn't explore because it was beyond our computational ability. But then we developed early computers, and that allowed us to input larger data sets and answer problems that had previously been out of reach. These new computers unlocked new areas on our mathematical map. Instead of walking everywhere, we can now ride horses. We can get farther faster, and we can access areas that were previously inaccessible. But there were still parts of the map that our computers couldn't access. Luckily, computers just kept getting better, and they allowed us to solve more and more complex math problems. As a result, our virtual map has transformed. We have roads and cars, and we're just reaching areas that were previously unreachable. Better computers mean traveling across this map faster and more easily than ever. The thing that he said was really important to understand is that quantum computers are not
faster one, but they are a better version of it. So basic idea is they are much better. Not faster, but much better.
faster cars. They're boats. A boat is not necessarily better than a car. They're just built for totally different terrain. So with our new quantum computers, we're beginning to navigate these new mathematical waters, solving problems and discovering areas that traditional computers just can't. My question for IBM is, what's in the water?
Wow.
What are the oceans that we're all of a sudden able to explore with our quantum computer boats?
I love this. I'm an analogy person, so I'm like fully absorbed in this now.
This is why I think a quantum computer is never gonna beat an iPhone. But I think that this is a better thing to offer the audience, like to offer you guys, instead of like quantum computers are just another exciting computer.
I guess what people are probably clicking on this video thinking in their head is, will there really never ever be a quantum computer in my pocket? And I guess that would be, will there ever be a flying car boat?
Never,
you know?
never.
Is the tech ever going to get to that point? It's just a question.
I just want to say I really appreciate your commitment to this
I love
analogy.
it. I love the analogy.
Guys, we have arrived. Where we have arrived to? This does not look like there's a quantum computer here. IBM Research Division. Here we go. That's a quantum computer?
Yeah, but actually this is a dilution refrigerator. This whole thing is basically constructed to keep the quantum computer very, very cold. 15 millikelvin. It's the coldest thing basically in the universe. It's colder than outer space.
So inside that is 15 millikelvin.
Yep. So here, let me show you the one that we can like play with. This is it.
This is a quantum computer.
This is a quantum computer. The quantum computer is a chip in this one here, but this whole thing keeps the quantum computer working at insanely cold temperatures like we talked about.
So this is all refrigerator technology.
So all of these cables that you see here on the side carry signals down through the fridge into the processor, and then they do their quantum stuff, and it comes up and it goes to these room temperature control electronics, and they turn it into things that humans can understand.
That is a quantum computer. We were allowed to touch it, which was cool.
Oh my god.
Yeah, this wave theory is very important here. It is the main able thing, or the main thing which works with the quantum computer.
State or the excited state. And everything that you type into your computer, like all words, all numbers, all colors, get translated into computer speech. But it's very binary, right? A quantum computer is run on qubits.
Qubits aren't like bits. They aren't a 1 or a 0. They're more complex. Think of this like a wave. A qubit could be really likely to be 0, which means a lower energy wave. Or it could be really likely to be 1, which means a higher energy wave. And each qubit has a probability of being each. When a quantum computer is working, the probabilities of multiple qubits interact.
And they add constructively or destructively, just like waves would. If you were to like tap like two places in a pond.
You know how when you like explain something to a 2-year-old and they just keep going, why? And they have to explain it again and you go, why? Yeah. My question is, as the controller of the computer, you decide what about those probabilities?
Basically, you are altering the probabilities while you're running an algorithm.
It's a common misconception that quantum computers try all the options. That's not right. This is simplified, but it's more like a quantum computer kind of watches the pond. It watches how all of those waves interact and then finds the most likely answer. If this is all confusing, don't worry. All you really need to know is that quantum computers calculate things very differently than classical computers do, and that makes them good at different things.
Quantum computers are not going to be faster at everything than a classical computer. Like, it's not good for addition, right? Because your calculator and your phone is perfectly good at that. But the things that quantum computers are good at is finding structure in tons of data. And if you're interested, we can close it back up.
Absolutely. Put us to work.
So basically everything is quantum.
Let's go back to our virtual map. So we have our boats, and we're floating around discovering new parts of this map. One of the first new areas of interest is simulating nature.
Simulation of nature seems really interesting. Why is nature one of the things?
So nature fundamentally is quantum, and it obeys quantum physics. We just don't normally see it. But if you look at like a molecular level and like the atomic structure of molecules, everything has to follow the laws of quantum physics. It's really hard to calculate what a material or what an atom is going to do past a certain size. So at a certain point, it just can't do it. But if you're interested in like developing battery technology or creating new materials that have
Very interesting. This was a good video, and this is all about the quantum computer and the working structure and everything about this. And maybe this is all about, and basic is quantum computers are another level. So this was the basic idea of the quantum computer. I hope you like this video. Please like, share and subscribe the channel. That's it for today. Bye bye.